The problem is the erosion of trust on the internet. I think cryptography is a counterbalance to AI. There was a version of the internet, and in a far future, it became so flooded with misinformation and synthetic content that it became unusable. We are the information society. It's so important to have it. And this is like a cautionary tale of what could become of one of the most significant creation, the internet.
Every prover network out there right now is not actually that privacy preserved.
Not zero knowledge.
Not zero knowledge. That sounds kind of bad.
It can be. Any piece of information on this internet, it comes along with the cryptographic proof of its origin. In a switch of the toggle, you can filter out all the synthetic AI content. Imagine how nice that would be. We can navigate this internet, we can trust what we see. It's so crucial for our information society to have that.
Welcome back to my channel, where we help off-chain Luddites become on-chain sovereigns. Every week here, we share the tools and mindsets to helping you unlock your digital sovereignty. Today, I am here with my good friend, Timofey, or Timo for short. He is a prolific researcher in zero-knowledge cryptography and related fields, and evidently a photography nut.
Nice to be here, Tim.
And too.
I'm excited.
Evidently a photographer.
Oh, yes. Yes, I am.
Here. So Timofey and we spent years in the trenches working at a company called ChainSafe. He's still there. For years, I was trying to explain what he was building, and inversely, he was building stuff that I couldn't explain. Yeah, Timofey, would you like to take a brief moment to introduce yourself and what you do, and what are the problems that keep you up at night?
Yeah, we had a lot of those back and forth trying to ironing out technical details for our community posts so that like regular readers could understand that. I was kind of notorious about writing a lot of stuff myself. It's not because I wasn't like trusting other people to do that, but because I genuinely enjoyed writing myself, especially if it's like educational articles, tutorials, like development tutorials. Another thing was that I was like really into learning new things. I always wanted to learn new things. And of course, the development. I was a software engineer at the time. But this realization about like writing and constantly learning pushed me to switch from the software engineering into research. And that's what I've been doing for a bit over 4 years now. My work, it always starts with some kind of problem, some kind of improvement that needs to be done in a library, in a protocol. And then from there, I study the problem, I find the right tools, propose the solutions, specify them. And then the most fun part is I develop the prototype to show that this solution or solutions are actually work. And then sometimes, more often lately, these prototypes grew into actual projects, open source projects, of course, and my research work becomes cryptography engineering.
So full end-to-end, like research to development, and then like you're almost like bootstrapping like whole ecosystems, it sounds like?
Yeah.
Wow.
Like looking for grants, a lot of things. Yeah, I love that. Like in terms of expertise, for the longest time, I've been focusing on the zero-knowledge cryptography that you know of.
Yeah.
That's the articles we've been writing together. But lately, I've been working quite a lot with multi-party computation, MPC, fully homomorphic encryption, the FHE. You know, this ZK, MPC, FHE, the holy trinity of programmable cryptography. It's amazing how these things can complement each other. And I guess what keeps me at night, what kind of problems drive me. The problem is the erosion of trust on the internet. Now that we go on the internet, we cannot trust what we see. We all know why. And I think cryptography is the best long-term and the emphasis on robust solution. I think cryptography is a counterbalance to AI, and I'm excited to move more and more into this area.
Wow, lots to dig into. You mentioned a lot of things with a lot of buzzwords that I don't fully understand. And then also the thing about bringing trust back to the internet, a lot to dive into there.
Yeah, we'll unpack that.
I will absolutely stand for something like that. Why don't we just give a brief introduction to where we are?
We're in Taipei. We're in Taiwan. We are in Taipei. Excited to be here. It's my first time here.
This is actually a place that I suggested we go to because apparently it was good for street photography. Yeah, we'll call that the intro. How long have you been into photography for?
Not long, man.
Not long. This is a relatively new obsession.
Oh, yeah. It's been 2 years. And the first year, it pretty much, when I moved to Berlin, I got a film camera and I started enjoying the analog film photography, trying different film stocks.
Yeah.
But it was still more of an occasional, you cannot take that many pictures on a film. It's hard to practice because you don't have that instant feedback loop with film. Right. You wait like a few days to a week or more to see how that picture turned.
Right.
And so about a year ago, I bought a digital camera, and then that's when I really started to shoot much more.
Oh, I think we're here. Just a little update. We had to transition from our previous shooting location to a market because it's kind of raining. So we're now here in this market called Jingfu Market. That means lucky market.
I'm bad at remembering names here.
Yeah. Oh, good. Timofey, you flew here all the way from Berlin, Germany to Taiwan with a camera. Ostensibly, it could be worth more than the plane ticket itself. I'm not sure. It's a long way to come for, I don't think it's a work trip. So what's the mission here for you in Taiwan? Are you chasing light, privacy, or both?
Actually, it's exploration, man. I like to drop myself into the new place, new culture, immerse myself in it. The camera, the biggest thing is it's a motivation factor for me to go out there and like thoroughly explore. It's also about capturing the moment, the frozen moments into the still images, share it with everyone, or with just one person. Someone recently told me this idea is that if you share a photo with just one person, it's like just two of you in a whole universe saw that exact moment from that exact perspective. And I think it's beautiful.
Very intimate sort of thing. So it sounds like you do a lot of portrait shots then, or
more of a street photography. So
just talking about
kind of these candid shots of people just doing their thing.
But it's a very beautiful, like poetic thing that you communicated, right? Like you're just trying to, there's just this one moment in time in the universe where like you're just there at the right time, right moment, right place, and you just capture it. And
it's like a combination of a person doing their thing, immersed, the light, some light shining through the roof, the color that it creates, this exact moment of physical beauty, emotional beauty, the person being them.
And what kind of camera are you rocking down there, brother?
It's a Fujifilm X106, a bit of a hyped camera. Was hard to get it, but it's a fun.
It was hard to get.
Yeah, I needed to wait for like 3 weeks or a month.
It's like a high demand camera.
Yeah, it's hyped. Even like the previous version is still very much in demand. It's a very fun one. It's light, it's compact. It's a half frame, but it works really well with a big sensor. But it's a fixed lens camera, so you cannot swap the lens. And that would be a deal breaker for many people, but I actually love that constraint. It pushed me to move a lot, to find the right angle, and also be very creative with the composition. I think it's similar how it is in tech. Historically, the constraints, as in limitation in hardware or like boundaries of the protocol, it created the best innovation through creative solutions.
Constraints like facilitate creativity in a lot of senses, right? It's like art wouldn't be art if the canvas wasn't limited in size and the paint wasn't limited. And
the choice of color, the choice of brushes, same thing with tech, the choice of how much RAM can you utilize, which primitives do you have.
I love the nerd talk. And we'll make sure to pop up some of your street photography throughout the video.
Yes, sir.
Especially after this section. Cool. Great answer. Thank you. All right, we're now sitting down here. Like, what is this place?
It's almost like brutalism style cafeteria and a museum.
Where you're not allowed to film professionally. Yeah, you have an obsession with photography, as I can tell, and from all the B-rolls I've been filming of you already. Photography can be said is essentially just trying to capture the emotional resonance, the oomph of any given moment. And you're trying to translate that and then be able to like put it into a print format. Let's say, digital format. You're trying to do that without losing any fidelity of that given moment. And you're just trying to be able to translate that perfectly for someone looking at the photograph afterwards. In zero knowledge, you're kind of doing the same thing. You're trying to prove something is real without revealing the full picture. Is that a fair analogy, or am I butchering your life's work? How would you add more to that analogy, or how might you change it to explain what you do to the masses, such as my audience?
No, you're not butchering my work, definitely. unfortunately. I actually like that direction. Let me build up on it. In zero-knowledge cryptography, the zero-knowledge cryptography is best for two things. First is succinctness, or you can say compression, where you try to condense as many details and facts into one small statement, the proof, that you can check. It's similar with the photo, where the photo is one single perspective, the view on our large, highly detailed 3D world, but it can still show that something happened, that some person was there. I would add another analogy, semi-related to the filming topic. The film trailer, the 2-minute film trailer, can convince you that there exists a 2-hour movie with some plot, without requiring to watch it fully or like actually disclosing the movie for you. It's quite hard to make an analogy for this compression thing, because it's quite fascinating. You can do almost infinite amount of computer work and you can pack it into a single proof. And then the second big thing is the zero knowledge. It is semi-related to privacy, but what it essentially is that small statement, the proof, it does not reveal certain details. It will reveal something, it will reveal some fact, but will omit telling some details, some private inputs. So I will stretch the photo analogy here a little bit. Imagine the shot where one person is clearly visible, well lit, but there are other people in shadows. They kind of fade into shadows, so they're in a way anonymized. Yeah, I would make that analogy. Yeah, in fact, I did shoot this kind of shot on one of the conferences in Berlin, so you can add it.
We'll throw that into this video right here.
If you allow me to extend this analogy even more to
Please.
To multi-party computation, MPC, and FHE.
Which is also work that you also do research in.
Exactly.
Is MPC and FHE sort of falling under the umbrella of zero-knowledge cryptography?
No, it's separate cryptographic primitives. As I said, the holy trinity of programmable cryptography. You can say that the classical cryptography is encryption and signatures. Encryption is about hiding information, privacy, and the signatures is about creating trust. And so the advanced cryptography, the programmable cryptography, takes two of these primitives and make it, programmable. So the trust part, the signatures, become zero knowledge, where you can do any type of statement into a proof, a kind of programmable signature. And encryption becomes fully homomorphic encryption, when now you can not just lock the information in a safe encrypted and then open that safe, so decrypt. Now you can do something with that encrypted information in between, do some arbitrary computation. And the multi-party computation, MPC, is kind of a similar primitive, but it does this not through the hard cryptographic problems, but rather with information theoretic tools like differential privacy. Let me build up. Let me build up on it. This is a lot to take, and so we will wrap this with the photo analogy for MPC. Now I'm talking about MPC. Imagine 3 photographers who all of them take a photo of a same building, but from 3 different vantage points, from three different streets. And it's a fairly mundane building. From just one photo, it's hard to guess what this building is, where it is. But if you combine 3 of the shots into like a collage, then you can figure out that's the building on this street or some details about this building. So the multi-party computation works in a similar fashion. There is 3 or more parties who secret share their private inputs, and they compute some function on this secret shared data that gives the result share, which can then be combined to get the actual result.
Are there like practical examples of MPC actually? Like how might like you and I, how might these ladies in front of us like meaningfully engage with MPC?
The good example that I have in my head, and it may be not as much for the regular user, but it is for institutions, for say corporations as well, is doing some useful analysis on the healthcare data. So healthcare data is like historically notoriously hard to use because there's so many regulation of where it needs to be stored.
Privacy.
Exactly. Yeah. But it's useful to do some analysis for the advancement of medicine.
It's just so much data that like you could use to like infer something about, like an illness or, what type of people are more susceptible.
In the model that will be used for like cancer analysis, cancer detection, it just sits there in a server, so the medical institution, the clinic. And what the MPC allowed us to use that data. So there would be, say, 3 hospitals. Each of them has their own database, the log ledger of their patient data. And together they do train a model for some illness detection without actually sharing that data and revealing it. I think that's a very useful example. The analogy for FHE would be, imagine a blindfolded photographer who takes a photo of you. It's quite a bit of a stretch. Yeah. But we'll make it work. We'll make it work. The blindfolded photographer. Yeah, very.
By sense.
It's hard. It's hard to take a photo blinded. Imagine that blindfolded photographer who take a photo of you on an analog film camera. It takes the shot and then it gives you the undeveloped film roll. You go through the film lab, you develop it, and here you go. You have a picture of you. Hopefully good one.
Hopefully.
So in this, the blindfolded photographer is the FHE server. It does this computation, takes a shot without actually seeing anything. The undeveloped film is the encrypted result. And then the act of developing film is, it's an analogy for decrypting the result. The final picture is what you get.
Love that analogy. What's the practical examples, or like how might I meaningfully come into contact with FHE?
That would be any cloud computation. Say you save your personal photos in a cloud, say Google Cloud, Apple Photos, but you don't want them being leaked or the company seeing them, but you still want to have them like analyzed. So this is a photo of that person, this is a photo of a dog. So FHE sounds like a perfect thing for that. You encrypt your photo on your phone, you send it to the cloud, it's stored in a cloud, but then it can still be used for some useful computation. Yeah, sounds very useful. The only problem is that, as in our analogy, taking photos blind is very hard. In reality, with FHE, it's very compute intensive. That's the big limiting factor. And we're not sure that we could ever make it really viable. It seems like, I'm not too big of an expert, but from what I'm inferring in the industry, it seems like the innovation in FHE is very slow. We only have like 3 generations of schemes, whereas compared to, say, ZK or MPC, there's such a big variety of schemes of ideas.
When you say schemes, how do you mean? Like, so is someone like plotting to make FHE or whatever work?
It's a bit of a, let's say, scientific term. You can say the protocol, 3 generations of protocols.
I see.
But a scheme would be a smaller thing. So protocol is something like bigger. It would be a, say, combination of schemes and multiple schemes. So a scheme would be like a smaller in that hierarchy.
So then like something that's more fleshed out, developed at seeing practical use cases like zero knowledge. There's hundreds of generations of schemes that is making it more secure and safe to use.
Yes. And also more diverse. You can apply it to more things, more use cases. So that would be server-side proof generation or a client-side proof generation. So we have that choice. We have that variety of schemes to choose from. FHE is a bit more limited.
Thank you for the answer there. How did you learn cryptography, or like what resources do you consume to put yourself in the right like state of mind to like capture?
The first advice, and advice can be applied to a lot of things, is that fail first 100 times and then 100 times more. Just put yourself out there, take as many shots as you can, see how it works, play with settings, and you'll become better. So that's definitely what happened to me. Like I'm looking on my shots for like half a year ago and I cringe how I shoot it, how I edited them. That tells me that I grew in this thing. In terms of like resources, I subscribe to subreddits for like Fujifilm or some analog photography geeks, and I just look the posts, or sometime like search through Reddit. But I would say still not as much resources. I feel like with this hobby, I like to figure it out myself. For the longest time, I've always been like a self-learner.
Right.
I feel like I'm not as good as like for me being taught how to do something. I just want to learn the damn thing myself.
Was crypto also sort of a similar rabbit hole for you, where you just kind of fell into it? And
yeah, definitely. As I said,
was it intentional?
It was, man. It was, wait, let me take a picture. Talking about interesting buildings, hey?
You're trying to capture the emotional resonance of
a building.
Yeah. it exists in that one moment, that intimate moment between you and that building in the universe.
Right. I'm one of those 3 photographers in NPC analogy. Hopefully not from the FHE analogy, not blindfolded. Going into crypto and then cryptography was sort of a direction for me. Like I started from a very centralized software engineering. I was working on this ERP/CRM platform in Ukraine. Then I moved to more like cloud development, a bit more distributed. Then the next move is decentralization. So that's when I moved into crypto. Then I quickly realized that, I actually like tinkering with something like holistic, something that I can break down, reassemble. Fell in love with cryptography very fast. See how the parts fit together, how they work together. With cryptography, it's certainly a bit easier compared to distributed or decentralized compute systems where many of the parts, they're like physically far away from you.
Right.
And it's hard to grasp it all in your head. With cryptography, it's a bit easier, but it has much more depth.
You sent me like with your recent blog post, I forget what it was about, but like I saw math and I was like, I don't know.
Maybe that one was about circle Starks. The Stark is one of the types of ZK proofs, scalable, transparent argument of knowledge. And I wrote an article about it, explainer, tutorial of how they work. With this article, I had something special. When I was in Invisible Garden, the residency in Chiang Mai, I met a Chinese person who translated one of my articles into Chinese and posted it on WeChat.
That's got to be some validation right there. Holy shit.
I felt something new.
Your work is out there and people are like willing to translate it. Like that must be an incredible feeling of recognition and like your work is impactful and useful.
Exactly. That's what I liked about this. My work is extended to more people.
By the way, we're heading to the botanical gardens where we're going to continue our line of questioning, my interrogation. We're now here in the botanical garden. Oh, it's actually quite beautiful. In photography, there is this tension between, not just photography, I feel like a lot of different fields get into this sort of tension where you have these gearheads and gear nerds. In photography, people talking about body and lens and filters and ISO speeds and shutter and exposure and blah, 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 all the bells and whistles of cameras. Then you have the artists who might just want to sit there and capture the moment, capture the building.
Right.
Similarly, in zero knowledge, you have these researchers doing moon math, as we were talking about. And and people like me who just wants to sit there, use privacy tools. Hopefully it's on by default and I don't even have to think about it. So as a researcher, somewhat of an engineer sometimes, how do you navigate that sort of divide?
Quick run down the history of the zero knowledge. Let's focus on this. So the zero knowledge cryptography started in a very research territory. So we had a specialized arithmetic circuits we were developing, and they were very single purpose and very math heavy. So only people who were deep into this field knew about these tools and primitives were able to develop them. And that hindered the development time, the innovation quite a bit. Next, the industry pushed for developer experience. And we had zero knowledge virtual machines, which allowed to prove any piece of code written in Rust or C, and that changed quite a bit. It allowed regular developers to tap into the verifiable computation. And then shortly after, the prover networks start to pop up, and that allowed developers not to care as much about the heavy infrastructure to deploy their verifiable computation applications. There is a catch. These prover networks, they are not zero knowledge. They run zero knowledge virtual machines, but they are not zero knowledge, as in they don't give this privacy for the users who want to delegate proof generation. So the reason is that you need to send your full data to this prover network infrastructure provider for them to be able to generate the proof. And I guess it could be a bit misleading. A person would think that they get that privacy, but but
you're kind of giving up your data.
obviously. And so the development continued, and some of the developers tried to do client-side proving, essentially an attempt to make this heavy cryptographic provers work seamlessly on edge devices like smartphones. That worked to some extent. It's a nice line of research. The direction that I personally most interested is the private proof delegation. It's essentially making these prover networks, this convenient infrastructure for developers and users to generate the proof fast, not on their phones, but make it private by combining that with our friendly MPC and FHE, photographers, blindfolded. I use the photographer analogy once again. With MPC, you can hire 3 or more photographers to do your work, to do this shot, but they will only see some part of the whole picture. This works. This is quite efficient. MPC works quite well, but you're paying 3 photographers instead of 1. With FHE, you're hiring 1 photographer, but it's blindfolded, and it's really hard for them to do the job, especially to capture very specific details and not to show others. I tried it, and unfortunately, this doesn't work as well. MPC does, and that's when we get the collaborative snarks. And I think I told this story about the history of ZK, and I think it captures the direction of make things more developer-friendly and user-friendly. It started with something very hard and something that only researchers can use, and it became something that any developer can use, and now any user with the smartphone hopefully will be able to use with client-side proving or with private proof delegation techniques. That's the direction that I'm pushing. That's my contribution to this. As I said, I'm interested in a private proof delegation, and I'm working on making zero-knowledge virtual machines. So this convenient tool, flagship technology that allows any developer to build verifiable compute apps and make them privately delegatable. So yeah, as I said, make prover networks private. Make ZK VMs ZK again.
Hashtag. Can we just take a moment to appreciate this place is fucking beautiful. I had no idea this was here in Taipei. I'll just do a little pan shot for everyone. Incredible. So actually, this is the official Taipei Botanical Garden. It's my first time here, and I've been living in Taiwan for 6 years. So thanks to my brother for leading me here. And now we're on our way to a tea house. Our friend over here is a tea enthusiast, and he likes doing tea ceremonies. So we'll make sure to get some questions in there and also enjoy some tea. Ooh, mud. Sat down now. Timofey, this is our final stop. We're in the tea house. Tell me about your obsession with tea. Why did you want to specifically bring me here to close out our final part of the interview?
I think this is a good traditional tea house where you can brew it yourself.
And what are you suggesting we drink here today?
We're gonna get some oolong, because Taiwan is one of the biggest producers of oolong teas.
Famous for oolong.
My personal favorite, the shu pu'er, the ripe pu'er tea.
Nice. And when did this obsession start?
Longer than my photography obsession.
How did your soul kind of cross paths with tea? And what spoke to you about the art of tea in the same vein that like cryptography kind of spoke to your soul?
For me, it all started back in Kiev. There were a few hype ways, I would describe them like that. So there were a hype way of third wave coffee, so like all this pour-over coffee, B60. I kind of missed that one. But the next one was the traditional Chinese and like Japanese teas. And that's when I got hooked up. 2019.
Kiev, Ukraine.
There started to pop up some good tea houses.
Wow, interesting. In Ukraine, I wouldn't think that there would be tea houses in Ukraine and like that there'd be a craze around Chinese tea.
I mean, teas are historically one of the biggest beverages in Ukraine and I would say Eastern Europe, more than coffee. There was this wonderful tea house where they would go to some small villages in China or Taiwan or Japan and collect the harvested tea. They would bring it back to Ukraine. They would give some interesting name in addition to the traditional name. I vividly remember one, it was a red tea and they call it King Kong. It really hit like a King Kong. Since that time, at that point, I was starting to like hear these interesting stories about the tea, about the different teas, about the method of oxidation tea, the fermentation like puer. And I started to write them. There is so much depth in this.
Just like cryptography.
Oh yeah, like with many things that I like. I like the depth. I like this rabbit hole to get into, to explore. As I started to travel, I started to, especially in Asia, I started going into these traditional tea houses and be more and more exposed to people who make the tea. And they were so passionate, and that's definitely fueled my own passion in that.
Yeah, tea ceremonies, like I never really considered it as a thing to do, but I think I might start bringing that into my friend groups too. You wanna order?
Can we get the ding dong and
自己泡吗？
自己泡，对，
and choke puer?
哦，手鼓，OK，好，就这样子。
就这样子，谢谢。
Gai one?
哦，盖碗，OK。
In our, let's say, preparation conversations leading up to this filming session, you had mentioned stuff like verifiable AI, proof of humanhood, and bringing trust back to the internet. And these are things that I will absolutely stand for. Those are hard things and very ambitious.
Oh, yeah.
Which one excites you most? What's the actual path from taking some of the interesting research in these things to technology or products that human beings can actually use?
It will be hard, and I would say technically the verifiable AI is certainly the most exciting and seem like the most robust solution to the problem of erosion of trust on the internet. Unless it's a small model, right now it's not viable to deploy that at scale. For LLMs or for graphic models like that pop up images or videos, especially for videos. And that's kind of like where it's especially needed, right? This verifiability that we can check that was created by AI or not by AI. It seems like a sort of cat and a mouse game. The AI moves so fast and cryptography certainly moves slower. It needs to like catch up. This is where the tension is. The intermediary solution I've been thinking and other researchers been thinking is the proof of personhood, the proof of human provenance. And I think you talk about that with Oscar.
Yeah, the rock camera.
Attested sensors,
Yes.
right? From what I think to it briefly, some of the phones already have that. Like this Pixel phone, it has the API to get the signature of the metadata of the photo. There is like a secure enclave, small secure enclave chip that will get you that. So it is already in some of our pockets. So that is a big step. You already have like some metadata on your pictures. Like if you open your gallery, you can swipe a photo up and you can see some of the where it was taken, the time it was taken, what was like the focal length. Essentially, the big difference is that this attested sensor, they sign that metadata securely, so it cannot be fabricated. And that's the first step. So you have a picture with a signed metadata that can prove that it was actually shot physically by a human on a phone. It does not need to reveal the ID or something, it just needs to prove the fact that it was shot physically on a real phone. But then we need to do some edits. We always do some edits on a photo. We usually don't send them raw and don't post them on Instagram or somewhere else. There is protocols, there is application that allow you to do this series of edits like grayscale, cropping, verifiably, and you have that like verifiable editing history. Researchers like Dan Bonnet work on that, and there are more schemes coming up. And so in combination with this attested metadata photos or videos plus verifiable edit history, you now have a end-to-end proof straight from the phone and up to the final photo or video that you're posting that it was in fact created by a human and edited by a human. That's a succinct proof, so it can just be uploaded along with a photo or video and everyone can check. I think that's already very useful. We cannot verify that things were created by AI yet, but we can verify everything that is human, sort of like a reverse approach. I think recently even the chief of Instagram told that this is the way. Even with the tech figured out, I think that won't be quite enough. I feel like we would need some standards and probably even regulations to push that into the masses. Usually in crypto we are like a little bit anarchistic and we like don't like the regulations, but I think for this case and some others where the standards are really needed, that actually can be useful. Like the European Union is known for pushing a lot of the privacy regulations, and they're later becoming sort of a world standard. If the European Union, for example, would push for that, it can speed up things a lot and help that become reality. In fact, ChainSafe and 10 other companies recently applied for the European EU Horizon grant. This is the grant for the innovation. For exactly, that was one of the proposals that we suggested, this proofs of human content on decentralized social media.
So like the proof of humanhood stuff is what excites you most?
Not necessarily the most, but it is the direction that I feel is useful and practical, and it can solve the real problem. But I'm definitely also very interested in verifiable AI. You're probably even more familiar with the algorithm than me. YouTube algorithm, right? I imagine you're figuring it out.
I'm figuring it out.
It's like opaque, right? Like we don't know how it works. And it's okay for it to be private. It's like the IP of the company, but it would be nice to have some confirmation that it worked according to some rules, that it's not biased, that it's not hyping up some like bad things or overly bad things, kind of like extremes.
You also mentioned in our lead-up conversation that every prover network out there right now is not actually that privacy pristine.
Not zero knowledge.
Not zero knowledge. That sounds kind of bad.
It can be.
Can you walk me through why that might be the case for someone like me who thinks we might be using private crypto tools or private tools in general and actually might not be?
I wouldn't say that. I don't want to diss the prover network. I feel like they're being used for the purposes they're kind of intend to, and I will get to that in a moment.
Maybe even just kind of start with like proven networks. Like what are proven networks?
Prover networks are proof as a service infrastructure, where the example would be the succinct prover network or boundless by risk zero, where they run a lot of machines, GPUs or CPUs, to generate proofs efficiently, and you send your data to them. They generate a proof of some program of your choosing as well. You get it back. It's, in a sense, it's a delegation of the proof generation process. You don't have to run it on your own PC or your phone.
Because it might not be powerful.
Right. And as I said, they are not zero knowledge because you're sending all of your data. But that's okay for the application they're used right now, which is usually blockchain. In blockchain, you don't care as much, like in a public ledgers, you don't care as much about the zero knowledge, about this privacy. Say for rollups, you care much more about succinctness. You want to like compress as many transactions in one proof, into one block. But then there are plenty applications which are more user-oriented, which actually would benefit a lot for ability to delegate proof generation. The fact that they're user-facing means that users will use them on their edge devices, on their phones or their laptops. Proof of personhood, so they verifying that you hold the passport. It's a legit passport of some country. This is like verifiable identity. And it also can verify some of the attributes. Say you're older than 18, but it won't disclose how old are you actually. Just the fact that you're older than 18, or you're from some country or area of countries without actually saying which country exactly. That would be like verifiable identity. I think already that is quite powerful, and that can be used in many applications on top. Then that could be verifiable inference. So the verifiable AI inference running the model on some private data in a delegated manner. So you don't need to do that on your phone. With the verifiable AI, there is this kind of trade-off between private model, public inputs, private inputs, public model. You cannot have both at the same time with a classical zero knowledge, because you need to generate a proof. Someone needs to share that data to the other party. Say like the OpenAI holds the private model, and they don't want to release it, and you send them your data to do this inference to like run a chatbot, and they generate a proof for you. You shared your data. That could be the other way around as well. But with collaborative snarks, this combination of MPC and ZK, you can actually achieve that. Remember, these 3 photographers, each of them kind of take their own picture, so the analogy of them holding their own private input, here it works just perfectly. The OpenAI has their private input, you have your private input. There could be more parties even, and you collaborate through this cryptography and information theoretic primitive MPC to generate a proof. This is another very nifty add-on on top of the private proof delegation to be able to do that collaboratively. I know like Aztec were at some point pushing a lot for this private shared state. They wanted to be able to do private smart contracts, so that could be like decentralized exchange DEX with a private order book, and it's put on the blockchain as a proof. Yeah, for that you also need some sort of collaborative proofs and proof delegation. And again, you want to run it efficiently. You want for users to actually use that. That's another great use case for private proof delegation.
But they're not actually private.
Well, if we combine that with MPC, then we'll make it private. And again, it's like the combination with MPC not only makes it private, it also unlocks new use cases like collaborative snarks, allowing each of both parties to have their inputs private. From the verifiable inference, that would mean private model, private inputs. You cannot do that with just ZK. My current project is applying MPC to the zero-knowledge virtual machine.
Obviously, like MPC is like your thing, your jam. Like, are there
right now?
Are there limitations to like multi-party computation?
Oh yeah, certainly. It applies more broadly, I would say, compared to FHE, but it has the same technical bottleneck as the FHE as well, and this is multiplication. So the additions, like you can express any computation as just 2 operations, additions and multiplications, which I find already like quite fascinating. So the additions are cheap, both in FHE and MPC. The multiplication is what drives the cost. So the cost in FHE gets really high the more multiplication you do. With MPC you also pay that cost, but you pay that cost in communication. The 3 photographers, the parties, need to communicate a lot through the network. It's hard to say that without getting technical, but you kind of want your computation, the thing that you want to do, to be like linear. That means that you can divide it on many different parts. You know how like in a sum of operands you can change the order, and it is this kind of mathematical rules that apply very well when your computation is linear, and that allows to make it efficiently. But when your computation, say like model training, it's not linear, there is so much like non-linear algebra there, then it becomes really hard. But it's even harder in FHE, so...
That's where we get into the moon math aspects of...
Yes, we dipped our fingers a little bit in a moon math.
I'm just trying to think about like me as a layman. I'm going about in day-to-day life, having tea and just going to shops and like buying stuff, and like all of what you said is obviously like it seems rigorous and you know academic, but like it has to be, right? I understand, but how is that going to affect like the shop owner here serving us tea, or like how do you envision this, all of this stuff snaking out into the real world and like affecting how like your mom or my dad might be engaging with the world? And this is kind of a segue into the next question, and we'll get to that later, but yeah, sure. I'll give you a chance to.
I'm imagining you're going to the airport, you're passing through like the border passport control, and you're not showing them your full passport with everything about you.
But why not though? It's the
right
border.
We used to that, right? And but there are other places where you would need to show your passport. So you're like checking in into your hotel or Airbnb, and they ask, hey, I agree, yes. I need to scan your passport, and you're just giving it there. All
fucking bullshit. I'm pretty sure like they do some nasty shit.
Calm down a little bit and smell some puer.
Calm down.
We can agree that this is kind of the problem that could be solved. It would be nice to solve this.
Yes, 100%.
So imagine instead of like giving your passport, you just tap in your phone and it transfers them the proof, the signature that hey, you are the legit person, you are the citizen of some country, you can be trusted. It's the trust. It's that other pillar of cryptography that I was talking about, but made programmable. And so you can build many use cases on top of already this just verifiable identity. Another thing could be right now there is a push to make social media more safe for young children, for teenagers. And so Australia is putting on restriction on the age. But you know how they do it? They do it with a face scan. They use some kind of model by Meta to scan your face and guess your age.
And who knows if it's secure too?
Who knows if it's secure? It's not accurate. I heard it's like 2-3 years in either direction can be a mistake. But the reason why they're using it is that there's like regulation and just like public dissatisfaction to give Meta your passport, to show everything about you, to be able to let you on Instagram or somewhere. And well, that's perfect use case for verifiable identity. You're not giving your passport, you're just giving the selectively disclosed attribute that you're over 16. You can use it. I mean, I'm working on a more of a like infrastructure, lower levels. I'm always glad to work with more like application people to kind of push that technology, and also with developer advocate people like you've been to kind of push these ideas into the public.
DevRels and application builders, hit up Timofey. He'd be happy to help you. I wanted to pull on the thread about trust a little bit. Bring trust back to the internet, as if we ever had trust in the first place. Did we ever really have trust on the internet? And like, are we really bringing trust back to the internet? Or are we actually, for the very first time, just actually building trust into it?
Trust on the internet, historically, it was sort of like a proof of person, sort of proof of identity. Because before, recently, it was just humans uploading their content. And before, like social media, it was just a website that each human created to share their things. We were trusting this website as if we're trusting humans. And I think it's a good thing that we can trust humans. And that sort of trust existed. And it already got worse with social media, especially with the emergence of generative AI. Now we cannot trust what we see on the internet. Right. We can make like educated guesses and it can feel uncanny, but that will pass and it will be even worse.
You've made it this far. Thank you so much for spending the time with me. Thank you so much for sharing tea.
Thank you for having me.
Close your eyes. Imagine yourself being in the year 2030 and everything had gone the way you hoped. How are things different? What sort of invasive bullshit am I not going to have to put up with anymore? Like, how does that world look like to you?
Actually, would you allow me to first give you the pessimistic example, the outlook?
You want to give me the pessimistic example?
Yeah, I want to create this contrast between the pessimistic future and the optimistic future.
Because then you're building
the kind of branch out on this road. I feel like we are right now on this kind of junction, on the branch where we can go either direction. I will quote the passage from the speculative fiction book by Neil Stevenson called Anathema, 2008 book, before the AI emergence. There was a version of the internet, and in a far future, it became so flooded with misinformation and synthetic content, obviously by the kind of AI, that it became unusable by the regular people. People cannot get any information, and we are the information society. It's so important to have it. Only like augmented people who were able to sieve through this noise were able to sort of use it with trouble. And this is like a cautionary tale of what could become of one of the most significant creation, humanity, the internet, if we won't take the proliferation of misinformation and erosion of trust on the internet more seriously. So that's the pessimistic example.
Yeah.
Now,
it kind of sounds like we're in that right now.
It feels like we already sort of step into that territory, and hopefully we can step back or take another path in this dark forest. But yeah, let's take a breath and now think about positive, now think about optimistic 2030.
Drink some tea to think some positive thoughts.
I'm imagining in this future any piece of information on the internet, and the internet still exists, it's still usable. Any piece of information on this internet, it comes along with the cryptographic proof of its origin. It could be a small private privacy-preserving statement that this is a text or image or video or whatever new form of media exists on the internet is made by human. Or it could be a detailed, attested metadata that this is created by AI and it traced back to the particular model version. I imagine in a switch of the toggle, you can filter out all the synthetic AI content. Imagine how nice that would be.
Especially on Twitter these days, right? Or like, YouTube. Yeah, there's a lot of AI slop. Sorry, go ahead.
Yeah, that'd be great. I really want to have that toggle. And whenever you use like AI or other services, you can trust that they use the correct model, not the
biased,
weaker version or cheaper. And then of course, yes, that this model is not biased. According to many things, it can be biased. Maybe in the future there will be more ways, more direction of the bias, but it is all checked, it's verified, and you know what you are using, even if these models are still private, owned by the corporation. I think already that is in this imagination, it brought so much new trust. We can navigate this internet, we can trust what we see. It's so crucial for our information society to have that. Even though some of these things like fully verifiable AI and that corporations like OpenAI are giving you a proof of what exact model they're running there, not biased. It does sound a bit utopian, not going to lie. I think it's still worth thinking about this, imagining this, perhaps dreaming about it, and also discussing it, like writing kind of speculative fiction, optimistic or pessimistic, putting that out into the public discourse. And so I want to kind of wrap to thank you for having me and to doing your work, to sharing this complicated technical ideas to people, to put it out. Thank you, Tim.
just doing my best. I mean, I also want to say thank you. That was a great answer, and I'm really hoping we can tap into that side of the fork in the road where, in 2030, we can have that toggle.
Oh, cheers to that.
Cheers to that.
Hota.
Hota, yeah. Oh, it's kind of how it is. Congratulations, you've made it to the end of the interview. Do you have any final words for our viewers? And also anything you want to plug? How can people reach you on social media or on email if they want to collaborate on a research or building something project? Yeah, go ahead. The floor is, or the tea table is yours.
I wish everyone to be open to new ideas, to be explorative, adventurous, to travel the world and immerse themselves into new cultures, new things like tea or coffee or books, explore more hard and complicated things. Be safe on the internet, don't trust what you see. It's not trustworthy yet, we're working on this. If you want to learn more about my work, you can search me on a GitHub. It's null T, and there are more links there. There are some of my articles there, so feel free to have a look. There is my mail there. Feel free to hit me up. I'm happy to more discussions.
Amazing. Thank you so much, brother. We'll close it off by having a little bit more tea and enjoying without the pressure of a camera being turned on. Thank you for coming to Taiwan and visiting. I hope you've had a great time.
I am. I'm having a great time.
Nice. And you're onwards to Kuala Lumpur next.
Yes, to Malaysia.
To continue the exploration of tea, photography, privacy and zero knowledge, and connection.
And wonderful people.
Let's keep enjoying some tea and
hell yeah, brother.
Spreading the good word on good work in crypto. My name is Tim. This is Timofey. Timofey is doing great work in crypto. And yeah, closing out. Peace.